Hi, my name is Tim Lindquist, and this is a course introduction for SER321, Principles of Distributed Software Systems. It is a junior level course in the software engineering program, ASU's Polytechnic campus. The purpose of today is to introduce the course, to talk a little bit about the objectives of the course, the ground rules for being a student in the class, and also to give you some examples of where we're going in terms of the assignments that we'll be doing this semester. So let me start out by introducing myself. I'm the course coordinator for the course, and actually I'm the one who created the course. Again, my name is Tim Lindquist. I'm a professor and also the program chair for the software engineering programs in the School of Computing, Informatics, and Decision Systems Engineering at Arizona State University. That's a mouthful, but within, we call it affectionately SIDC. Within SIDC are computer science, computer systems engineering, industrial engineering, software engineering, engineering management programs. And it turns out that we're kind of a large school, and we have about 5,000 students in the school. So the software engineering program has a thread through it on project orientation, and one of the focus areas that we support is distributed and web, and that focus area is available to students online. And this course is the first course in that focus area. So, principles of distributed software systems. Let's start out actually with the syllabus for the course, and you'll see from the syllabus. This syllabus actually is on the Blackboard site, and it's also on a website that I'll reference. It's in the syllabus as well. First, show you the class website. There's a link to it within the syllabus. And if you go to that website, whoops, that's not the website. The website is actually the second of the two links. There's the main page for the website, and it's http or https poo as in Winnie the Pooh.poly.asu.edu/SER321. And on that website, actually you'll find that a lot of the material on the Blackboard site originated from this site. And in fact, there isn't anything on the Blackboard site that's not on this, and not everything on the Blackboard site actually is on, not everything on this site is on the Blackboard site. So the syllabus, in fact, the main things I wanted to talk about the syllabus are kind of, first of all, a disclaimer, we are in the middle of changing the prerequisites for the course. For SER321. So in the past, SER or CST 200 was the prerequisite for it. That's changing, and it's now recommended that you have completed SER 221. And it'd be better if you were either concurrently taking or have already taken SER 222 in order to take SER 321. And the reason for that is a higher level of software sophistication as well as deeper exposure to different programming languages and data structures as well. So that's one of the things I want to mention. And as a matter of fact, I am in the process of working with advising to go through and make sure that students have already completed those courses if you are already enrolled in 321. So I already showed you the link for the website. The other thing that's important on the syllabus, two more things on the syllabus. One of them is programming assignments, midterm exam, and final exam are the three different things that you'll have to provide. And the relative weighting for those, 40% is awarded for programming assignments. This semester in the online offering and the face-to-face offering now there are 6 programming assignments. Those all contribute equally weighted to 40% of your final grade. 30% for a midterm exam and 30% for the final exam. If you're taking the course through ASU online, both those exams you'll be required to use a proctoring service in order to take those exams. The other important thing here is that no late assignments will be accepted. In fact, there are TAs that do grading for it, so we'll try and get the grades back as soon as possible on each of the assignments. But if we have stragglers that don't turn things in, then we can't return grades and so forth until after everything has been turned in. So there's just an absolute policy. If you don't get it in on time, then wait till the next one. And also the mention about the TA and the instructor for the course. So I'm the instructor for the face-to-face course. There's a TA who will actually be conducting the online course. He'll serve as the instructor for the online course. So I say that so that in fact you realize that he is going to be responsible for a lot of different aspects of the course. By all means, if you want to send email to me, do that. Send me. Actually, the best thing to do is send email to both of us. But realize that I'm going to filter it, because if it's something that he should be responding to, then I'm going to wait and let him respond to it. But on the other hand, if it's something that I have to address, then I'm happy to address it. But he's responsible for the online section, and I'm responsible for the face-to-face section. The university has an academic integrity policy. All of the assignments in this class and the exams are intended to reflect your own individual work. And because of that, there's no sharing of any work. That doesn't mean you can't confer with other students in the class. I hope that you do, because that's a great way to learn. But on the other hand, when you turn in something, it's got to be your work. And in fact, I'll just kind of show you here. You will not be graded. Every source code file that you turn in. Let me just go ahead and go to so this is the command line on OS X. We're going to talk about the command line in the first session. Every piece of code that you turn in has to have a copyright notice and a right to use notice, and I'll show you an example. Java client. And let's just look at one of them. Yep. So you'll see that this is defining, may have to boost it up here for, sorry, we get used to the default font. Let's move this up. That's probably better, more readable. Every file and every class declaration has to be preceded with a copyright notice and a right to use notice. And you'll find there are probably 20 or 30 different example projects that we will read as a part of this course that I have created. And every one of them has this header file in it, or has this header set of comments. These are Java doc comments. Excuse me, we'll talk about Java docs a little bit as we go on. But in fact, these comments indicate you as the reader, when I distribute this to you, it tells you what right you have to use this. And it also tells you who owns it. So in this particular case, well, I actually use two different open source licenses. You won't see any of my software that is not open source, that has a free right to use. And I sometimes use the Apache license, and sometimes I use the GNU license. But you'll see, I won't distribute any of my software to you that is not open source. But all the stuff that I do distribute is open source, and I use one of those two licenses. It also has an indication of who the author is, with contact information, the author. And for version, all of my stuff, especially the open source stuff, is just the version is by date. So you can see it starts out with a copyright at the top, and then it has in this case, the Apache license. It has a reference to Apache, and that's the explanation, the detailed explanation of the license. So if, for example, this particular license allows you to take this and to make a derived product of it, and even sell that derived product, but you have to also publish the code itself, and with a open source license on it, right? So just because it's open source doesn't mean it can't be sold. It just means that it has to remain open source, depending upon the different license that's used. So the bottom line of this is your code will not be graded unless it has a copyright that indicates that it's your code, and also an author comment that provides your name as the author and contact information for you. All right, well, that goes right along with the academic integrity policy. Anything that you turn in has to self-declare that you are the exclusive author of it, and you should also include some right-to-use license in it. I don't care if you use Apache. I don't care if it's not even open source. You can do whatever you want as right-to-use as long as you provide ASU with the right to download it and transfer it, copy it, and use it in your evaluation in this class and actually other evaluation within the course. You'll find in the first assignment there's a more explicit statement of this, but you have to give us the right to be able to evaluate it, to make copies of it. We're in the process of being accredited, so we have reviewers come in and we need to be able to show them samples of student work and so forth, so we need to at least have that right in terms of the code. It's your code, not my code. And you make sure that you give the appropriate right to all of that code. So there's 6 assignments. There's lots of software that you're going to be turning in, and some of the software will be a combination of my software together with the stuff that you create, and just leave my my right to use and copyright on the software that you turn in. That's not a problem at all, because you have the right to copy it, you have the right to use it, and so forth. But make sure that on your code that you do the same thing. So for this course, of course it makes a difference for the exams as well, but the primary thing is the source code that you turn in is your source code, and you're saying it inside of the source code. Okay, so let me go back here. I think we're done with the syllabus. So now let's take a look at what the course is actually all about. And I'm going to go back to the class website. And on the class website, there is a link to the schedule page. And the schedule is a detailed schedule of the different materials that we're going to be going through for the class. I will talk in just a couple minutes about textbooks, but I want to point this out. Actually, the textbooks are referenced in the course outcomes document when we talk about that. But you'll see that this is divided into, I think it's 12 different units. All right, and for each of the units, there's reading material. There is also, in some cases, a lab exercise. Some of the lab exercises depend upon more than one unit, so you'll see the same lab exercise in 2 or 3 units. And in every case, there's also a set of class notes. And the class notes, so let's just take a look. The first one, command line and Linux tools. There's an HTML version of the class notes. So here it is, and it's indexed, so all of these are hot links to different sections. So for example, section 1.b, the basics of Bash, it divides into 5 different notes or 5 different pages, and then material in each of those pages. Personally, I don't find that form or modality as usable as the PDF version. So there is also a PDF version. We're going to start out with the course outcomes. So let me open up the course outcomes so that you can see what we're planning to do this semester. And I'm not going to do it out of here because I like the PDF preview viewer better, and I can show you why it makes sense to not use an embedded viewer. So here is the PDF file that corresponds to all that stuff that's in HTML files. And we're going to talk about it, but you notice that I have, it's actually, and this is preview, which is on OS X, but I'm sure Adobe Acrobat or any other number of different readers provide the same capability. I've selected the table of contents here, and in the table of contents, it's all indexed. Here it's a really simple index, right, because there's only 2 pages, but in the other ones, let's just for the fun of it, open up the next one. So here's the one we were actually taking a look at before. You can see in that one there are 5 different sections, and each of the sections have different components within it. Provides the ability to move around a little bit more easily within those. I hope you find these things useful. The other thing is that there's hot links within each of these things to example programs, and those hot links should all work. If they don't, let me know. Except actually there's some that are in C#, and since we're not using C# this semester, those links probably aren't active. Okay, so where are we going this semester? What's this course all about? About time we get down to the good stuff. So our goals are to understand better distributed applications, because distributed applications make up now of the vast majority of all developed software that in almost every application. So there's a lot involved in working with distributed and creating distributed applications. And we're going to take a look at some of the fundamentals of that this semester. So the first thing is kind of the context in which we're going to be doing all this development, and that is in Linux. We're going to look at the fundamental program development tools that are available in Linux, and that means working from the command line. We're also going to work in C++ and in Java. And Linux and C++ have a very special relationship. A relationship that frankly isn't very well preserved on Windows platforms, but it is very well preserved on other platforms, Linux and OS X. And we'll take a look at and talk about that in more detail. But the idea is that you understand and are able to navigate the underlying system and to be able to do software development in that context. So that's the first course outcome. So at the end of the semester, if you don't feel comfortable in working with the command line, working with the bash terminal, then I hope you didn't get a good grade because it's one of the outcomes. It's one of the things that you should get out of the course. So I'm going to kind of go these instead of in order. They aren't ordered in the order of that we're going to treat them, and that's the first thing we're going to take a look at. The second thing we're going to take a look at is a thing called externalization. And so if we're looking at distributed computing, right, we've got part of a program running here, another part of a program running over here. They have to communicate with each other, not only communicate, but synchronize. In other words, this program gets to a certain point where it really shouldn't go any further until this program over here gets that data that it's been passed or whatever and does something related to it. All right, well, in order to do that, we're going to be communicating information back and forth between these two programs, running programs, and realize the programs could be and should be on different, are most likely running on different machines. All right, so externalization is the mechanism whereby, in an object-oriented language, we take an object that exists, so maybe you've created a stack object in your running program. We take that stack object and take it out of the program. We externalize it from the program and send it over here to the other component of your program so that it understands it and it can do the same operations, has the same data state. So externalization, sometimes it's also called serialization. There are several different ways to support that. Most languages have built-in fairly efficient mechanisms for serialization, but the reality of the world is, that's why we're looking at, and this is why we're looking at two languages. The reality of the world is that one of these components, one of these distributed components of our application is written in C, and the other one's written in Java, or it's written in PHP, or it's written in JavaScript, or it's written in something else. So we're going to use C/C++, which is very common for server-side stuff. And then we're going to use Java primarily on the client side, but we'll have some Java over here on the server side too. So to say that externalization, we want externalization to apply between different languages, programming languages, and that was honestly the reality or the beginnings of XML, and then another standard called JSON. So XML, you're probably already familiar with. JSON, you may or may not be, but it stands for JavaScript Object Notation. It's a very simple, primarily text-based way of describing objects. So externalization is the second thing we'll look at. Then we're also going to take a look at the common paradigms for doing distribution. And to just give you a very quick, one's client-server, the other is service-oriented, and then peer-to-peer. So, for example, if you're doing a game, a distributed game where different players are able to share information, share their screen and so forth, that's peer-to-peer. If you're working on the web with a browser and a server, that's client-server. So we're going to look at client-server and peer-to-peer. We're going to spend most of our time in client-server because almost every implementation of peer-to-peer is done where the client is a server and the server is a client. We're also going to take a look at object-based distribution mechanisms. And remote method invocation is a Java technology that as it evolved, several other ones evolved in different languages, so it's pretty representative. And then going back to a long time ago, a thing called remote procedure call has been around. And in a very real way, it's been resurrected primarily because of JSON. We're going to take a look at using remote procedure call together with JSON. So, and then the last thing that's important is that we have concurrency, threads, and synchronization. And that's the very first one that's on here. I'm not sure why it's the first one. It's almost the last element that we'll look at this semester, but we need to have the situation where the servers that we create can be talking to 10, 20, 50, 100 clients at the same time. And in order to do that, we have to have some element of concurrency, some mechanism in the server where it can be communicating multiple clients without starving one of those clients, right? So if one client is in the middle of waiting for user input, we don't want the server to be waiting for that client only when 5 or 6 other clients are over here and they actually want to do some communication with us. So we'll use concurrency. In particular, we'll look at threads. For all of its faults, it's probably the most common of them all. So now what about class resources, course resources? So this is the last one in terms of the introduction. And these are all things that are available elsewhere on Blackboard and also on the class website. There is a resources page. I've already talked about the schedule page. The resources page that describes all of the different software that we're going to be using. Actually, there are a couple of software packages that are described here that we're not going to use, but most of the stuff that's on the resources page is stuff that you should pay attention to. There are 2 books. One of them is Java Network Programming, the 4th edition. And if you want to, you can buy it. That's fine. It's actually a very good book, and it's worth having. It covers probably 70% of the material that we're going to be looking at this semester, and it's a good book. So the other one, I got to go back to you. And the other one is an older book. So Java Network Programming 4th edition, I think, is since 2010, and Java Network. That should be Network Programming and Distributed Computing, not Java Network. This is actually an older book, and it's about 2002. It's also a good book, and actually its coverage is a little bit closer to what we're going to be covering in the course. But it is, since it's an older book, it's a little bit out of date, but not so much so actually. So it's a good book as well. All right, so let me just tell you that I haven't paid for either one of these, and I suspect that you can do the same thing. There used to be a link, I thought I got rid of all of them, on my website, on the website for the class, that was a link to the PDF file for this Java Network Programming and Distributed Computing book, but I'm sure that the publisher got after David Riley and required him to take down that link to the PDF. Nevertheless, there still are, if you do a Google search on both of these book titles, I can almost guarantee you'll find a PDF version of them that you can download. And I don't think I violate anything by telling you that. You might by downloading it, but that's up to you. Okay, so there's also references C++ development. The Wikipedia page is really good in terms of explaining C and C++, but again, it's aimed at the level of someone who's already gone through a comparative programming languages course, and that's why 221 is so important. And then we are going to use 2 different computer systems this semester. One of them is a development environment, and the other is the deployment environment. So what I want to do now is to kind of transition and show you where we're going. So this is probably going to take 5 minutes or so, but I think it's probably worth doing so that you have an idea. I am one of those kind of faculty members who refuses to make an assignment until until after I've already programmed it. So I've already finished your assignment number 6, the last assignment, and I want to show you my solution for it, and I want to show it to you in the context that you'll be developing it, so that you understand where we're going. Some of the software I'm going to give to you, but most of the stuff, especially the distributed stuff, you have to do yourself. So a development environment and a deployment environment. The development environment is exactly for that. It's software development, and since this semester is the Learn How to Use Linux semester for you, it's all on Linux. So what I recommend that you do, not recommend, you're going to actually be required to turn in software with screenshots from a Linux development system. And if you follow this link for the development environment, it'll show you how to set up what I'm about to show you, and that is a VirtualBox environment. So here is VirtualBox, and you can see I've got two different, they're called guest operating systems. This is running on a MacBook Air laptop. It's actually about 4 years old, 3 or 4 years old, so it doesn't have to be the latest technology in order to get it to work. But one of the guest operating systems here is the development environment for this semester, and I've called it Wheezy VirtualBox. And let's go ahead and start it up. So right now, Linux is booting, running on this OS X device. And when it comes up and finishes coming up, there is a login screen. So there are lots of different options for you to pick for development on Linux, and you can pick whatever you want. I will specify when we get to the first assignment the exact format that you'll have to use in order to deliver your software. I will specify what it has to compile against, both for Java and also for C and C++. But I'm just going to show you in class. GNU Emacs is my editor of choice. And I'm going to actually require that you load LX Terminal onto your VirtualBox Linux environment. So this is a bash terminal session on that Linux box that's running on top of my Mac OS X. Okay, so now the other environment that we're going to use this semester is this guy. This is a Raspberry Pi. Raspberry Pi is actually a British computer which has received popularity beyond belief. The original intent of the Raspberry Pi was to provide a $30, I think it was probably originally a $25 computer that anybody, it was intended to encourage kids, to youngsters, to get involved in computing with a very inexpensive platform in order to do it. So we're going to use this as the deployment environment this semester, meaning that we're going to run servers on this thing. So it's also going to be a Debian Linux environment, and there are web pages on the class website, and those will end up on Blackboard as well. They're not there right now, but use the POO site as a reference for it. I think it's the third programming assignment requires you to have one of these things and have it configured. So depending upon whether or not you're taking the course through ASU Online or face-to-face, the face-to-face version of the course is 15 weeks and the ASU Online version of the course is 7.5 weeks. I didn't mention this, but each of those units are pretty much equal amount of time. So if you're taking the course in the 15-week version, then it's about one of those units per week. If you're taking the course in the ASU Online, then you've got to finish 2 of those units every week. And for some of the programming assignments, that's a significant amount of time. I hope you're not trying to take any other course, and I feel sorry for your boss if you're employed and trying to get through the course in that context. So anyway, so this is the Raspberry Pi. With OS X, it's very easy to configure it. So you can see I'm doing my networking through MacBook Air, and I'm just going to go ahead and power this thing up now so I can log into it. You can also, so Raspberry Pi, you can do it just at home if you want to, and they all come with a wireless USB wireless for it, and it will configure itself. It's kind of a pain in the neck if your router requires authorization, but it's reasonably straightforward. The easiest thing is the way that I'm doing it if you've got an OS X device. With OS X, let me just show you on the screen here, under System Preferences there is a sharing panel, And under sharing, if you do network sharing, you can see what I'm doing is sharing my Wi-Fi connection with the Thunderbolt bridge, which means whenever I hook an internet device, an internet cable up to my laptop, in fact, it will do port forwarding and also take care of all the networking essentially for the Raspberry Pi. Okay, so now the Raspberry Pi is up and running. So let's go ahead and get things going here. So the application this semester is Media Player. So let me get to the directory for it. And I'm going to, oh, I don't want to do that. Start up, actually I'm going to have a bunch of terminals here because it's a distributed, it's a course on distributed computing. We're going to use multiple terminals to provide for different active programs. So I'm going to start up the clients in the one that I just created up here in the upper right of the screen. But in this one, let's get onto the Raspberry Pi. So I'm going to log in, which is essentially transferring control to the Raspberry Pi. And it turns out my user ID is same as my ASU ID. So I've entered SSH to Lindquist at 192.168.2.2, and that's the Raspberry Pi. I know that that's the IP that the OS X assigns to any of the clients that are directly connected to it. So the Pi is asking me to authenticate. So what's the advantage of doing it this way? Well, you can, if you want to, hook up a USB keyboard and a monitor to this to configure it and to use it. But honestly, I'm lazy, and being able to connect to it from the command line, it actually has virtual desktop stuff if you want to do that too, but you really shouldn't need to do that this semester. So now I'm on the Raspberry Pi, and all the commands that I enter in this lower left-hand terminal are being executed on the Raspberry Pi. So I need to have another one on the Raspberry Pi because you're going to be doing two different servers on the Raspberry Pi. One of them is serving up essentially information about media. In our case, media are songs and videos. I got something wrong there. So now I have two different terminals running on the Raspberry Pi, and in one of them I'm going to start up a download server. So it's going to allow any client that connects to it to actually download a media file. So we're not going to store media files on the client. We're going to require them to be downloaded from a server. So let's go ahead and get that started. Yeah, let's see if I can avoid building here. Yeah. So I'm going to start first the name server for it, /bin / media library. So this is the media library, and it will serve up the names and author information. So in this case, you can see it echoes out which different media files it has. I've just got a couple of sample ones that it shows. Let's get the download server running here. I don't remember the command, but I've got it in the ant file. So you can see, I don't know how well you can see, but it's actually quite a bit slower. You wouldn't want to use the Raspberry Pi as a development platform. It doesn't have an internal disk, and because of that, it uses the SD card. And where's the up-down server? There it is. So the download server is written in Java, and the name server or the library server is actually written in C++. You'll be doing the exact same thing this semester. So I just started the C++ server in the other window, and now I'm starting up the Java server here, which is going to support downloading things to the client. So a little message comes up and says that it's running. So now let's actually take a look at the Java server. So doing compiles and everything else is much, much faster on the Debian Linux than it is on the Raspberry Pi. So remember now the two lower terminals that you see are both logged into the Raspberry Pi, and that's where the servers are running. And now let's start up the client here. Media library app. And when I start up the app, I've got to tell it which computer to go to in order to find the library and also to find the upload-download server. So the information that I'm entering here, this is actually at the end of a fairly long command line. There we go. So you can see it's a Java, right? So invoking the Java runtime environment or interpreter, you give it a class path, and then this is the package name of my program, Media Library App. And 192.168.2.2 is the IP address for the Raspberry Pi. And then if it contacts port 8080, that's where it goes to get this guy, which is all of the information of the media that's available. And then if it goes to 3030, that tells it where to go to do downloading. Okay, so now here's the user interface, and I'm going to give you all, actually I'll give you a Java class file which provides this user interface, and in addition to that also provides the ability to do playback. This is using Java FX, so that means that on our development environment, which is where we're running clients, which is what I'm running on right now, this VirtualBox Debian Linux, you're going to want to install Java 8. And actually, I'm going to be distributing some class files that if you don't have Java 8, they may not work properly. It won't compile with Java 7. So what happens with this, there's the component on the left panel here is what's called a JTree. This is a Java swing application. So it's a tree, and you can see the tree. You can expand and contract the nodes in the tree. And the way I've built the tree, I have one subtree for music and another subtree for video. So in the case of video, I've got 3 different videos, and they're all of the genre animation. And I love Minions, so they're all Minions. And then I also love oldies, so all the music is oldies. So the music is listed by what I'm calling albums. Whatever you want to do, it doesn't really make any difference. But that's the approach that I've taken. So now I have the ability, each time, I don't know if you've noticed or not, but each time I select one of the media clips, the information about it appears up here in the top of the right-hand panel. So that's the Jimmy Buffett song, Come Monday. Here's an oldie by Patsy Cline called Crazy. And then if I go down here in the movies, the videos, you can see Banana. So one of my favorites is Banana Song. So let's go ahead and just do that. I can, by adding information in here or changing information, I can remove clips from the library, just to show you how that works. So if I want to get rid of Jimmy Buffett's fins, I just do remove, and you see that the tree gets updated, it's gone. And you also saw down here in the server a bunch of stuff trailing down in the server. This is the server that's handling the information about each of the media. So when I remove something, this program went to the Raspberry Pi and said, get rid of fins. So it got removed from the library. So now if I started up another client, fins would not appear on that client. So just to show you the download server, we'll just do one of these and then we'll be done. Select Minions Banana Song. I don't know if you've ever seen this before or not, but I can do a play. I probably should have hooked up sound to the laptop. I didn't think about doing that, but you can see on the Raspberry Pi, the download server just got a request to download Minions Banana Song.mp4. And since we're using TCP/IP, the download is kind of slow, but you can see now what the panel is for on the right-hand side. So all of these controls that exist here, so they're singing, you probably can't hear it, but this is the Minions Banana Song. Was one of the short clips to advertise Despicable Me 2. We'll let it finish. So let me kind of just describe, so you're not going to have to do the GUI components, although you are going to have to build the tree, and you are going to have to put information into and take information out of each of these different elements up here. And the information that you're going to be putting in there and taking out of there is information that comes from this server that you'll be generating running on the Raspberry Pi. And all of the overhead for playing, so actually the GUI itself is mine and it's open source, but all of the play stuff, actually I think that's all open, no, it's actually Oracle's. So this is using FX2, and I took a couple of classes that are part of their tutorial and kind of glued them together with my UI stuff. So in order to do the playing and that sort of thing, it's not going to be a problem. You are going to have to learn some stuff about swing, or you will be learning some stuff about swing, and the corresponding thing in C++. But in fact, that's a totally different story. So it's pretty much just dealing with the common GUI components. We're going to use that as a mechanism to talk about model view control, MVC. Okay, so there's an example. I guess I should also show you. Let's go ahead and shut this. No, let's do another one. Why not? You're also going to be generating a C++ client. The client you were just looking at is a Java client. We'll wrap it up here. And the C++ client, you're not going to be required to connect it to the download server. We're not going to do TCP/IP sockets in C++, but you are going to have to connect it to this guy. I don't know if you just saw that or not. So this is using a toolkit. You will see as we go through the semester, C++ is a very low-level kind of a language. So there's nothing built in, like Java has swing totally built into it. With C++, you have to go and figure out which one you want to use. Do you want to use Boost or whatever other components are available? This is a set of components that were developed by a very well-known animationist, actually. It's called FLTK. Sometimes it's affectionately called Full Tick, but it actually stands for Fast Light Toolkit, and it's a fairly straightforward set of controls to use. So you can see once again that it creates a tree of everything that's in the media library, and then you can do selections, and it gives you the option to make changes to it, add new components to the library, and so forth. And again, if I remove or add components, then in fact all of that stuff gets communicated to the server and registered over there. And we do actually, so we can do playing here, but it's a much easier way to play. Playing is done with the VLC app. It turns out that VLC is an open source app for media playback, both video and music. Lots of different codecs are implemented, and it comes. You don't have to. It's no special download or anything. It actually comes with the image that we'll be using on Debian Linux. Okay, so let's leave it at that. So that's kind of where we're going this semester. Yes, you're right. There's a lot of code that's involved in generating it. I'm going to give you a lot of the GUI stuff, but there's still a lot of other code because you have to do servers. And actually, we're going to be we have one other programming assignment that has a server running on the Raspberry Pi. But you don't have to generate a lot of code for that. Mainly, that assignment is for you to get your Raspberry Pi up and running. Okay, I'm going to leave it at that for today. So this is by way of introduction to SER321. I hope you're planning on having a good semester and getting everything out of the course that I hope you do get out of it. And I hope that by going through this demonstration, you realize, frankly, the amount of time that you're going to have to spend in order to do the development that's necessary to implement these. And that's why I say both 221, SER321 and SER322 really are prerequisites for this course. Okay, so that's it for today. Thanks.